Hello, can you hear me? Okay. Mm, So, um, let's start. So we were doing, okay. So we said that there is a traveling wave that travels in the positive x direction, and then there is a traveling wave that travels in the negative x direction. And that's how we will represent that traveling wave, right? So we will start from here to see um, where we are going. So before I move further, I think I want to make another point here that uh, you can write this as sorry. Real part of e j omega t minus kx, and you can also write is as this is its exponential or phasor form. Okay, just a minute, I need to confirm something. Okay, so that's how we will represent it in the phasor form as well. So now if we move further, another thing is that we said that phase velocity was lambda f, right? And we can also write it as omega over k. If you see that, because your omega is 2 pi f, and your k is your wave number, which is 2 pi by lambda. So when you, because you, if you see here, this k was 2 pi by lambda, and omega was 2 pi f. So we can just write it as, and it will become as lambda f. So phase velocity is also equal to omega by k and lambda f. So that will help you solving the problem, that relation. Okay, so we are good till here. And one more thing is that when we started this problem, we ignored phase, right? We said that phi is equal to 0. So what if we put back the phi? We can also write it as a cos omega t plus minus kx plus phi. So if we writing it this way, then we are reintroducing phi, and I mean, it tells you that wave is leading or lagging. Okay, we will talk about this later. But phi is also there in the waveform equation. Okay, now one thing is whether wave is lagging or leading when phi naught is equals to 0 is your reference. What it means that, let's say you have a cos signal. So this is your cos signal, and this signal is cos omega t um, minus kx, right? So now you know that it starts where it should start. Like omega, when t is equals to 0, it will be 1. So there is no phase. But let's say if it starts from like this, but it's still a cos signal, and if it is t is equals to 0, then there must be some phase here. Is it clear? Because when we were talking about traveling in plus x direction, we were incrementing in time. But when we are talking about phase, we are talking about t is equals to 0. I want to move a little bit back. If you see here, here we draw at t is equals to 0. But if at t is equals to 0, your waveform instead of cos signal starts from somewhere else, it means that it has some phase in it. Michael, do you get it? Okay. So another thing I want to, we did in the first lecture, we were talking about standing waves, but we did not understand the relationship when I was doing it, because we have not done the traveling wave scenario. I know it's a little bit heavy right now, but it's very important to do it, because all the time we will encounter e raised to power something, and if we don't understand, then it will be hard. So it's really important that we right now cover these basics, okay? So standing waves. So standing waves is the superposition of plus x and minus x waves. And we know that standing waves are not traveling waves. Okay. So, so when the plus x and minus x waves are superimposed, then they will be produced due to constructive or destructive interference. Okay, so I want to write some mathematical form of standing waves to see what they are. So let's say if I have the plus x wave as ej omega t, ejkx, plus a real part of ej omega t, e minus jkx. One minute. Yes, minus first and then this expression, like the superposition, will be the standing waves. So if I write it, it will become real part of ej omega t, ejkx plus e minus jkx, and this will become you will see all sorts of expression, but the only concern here is that we are separating the time harmonic part, and we are separating, sorry, this is not kx, this should be kx, right? And we are separating the like the like the space and time parts are separate now. So this is your time part, and this is your space part. So when they are not interlinked to each other, they are not supporting each other to travel. Instead, they made standing waves by moving up and down like this. Okay, so we are actually separating the time and what you should say space part in standing waves. Okay, is it clear or is it confusing? I can do some, some more explanation if it is confusing. Aaron, what do you think?
I think it makes sense. I'm just confused of where the divided by 2 comes from.
So we multiply with 2 and divide by 2 to make this as cos, because your
Oh,
cos is
okay.
equal to 1 by 2 ejx plus e minus jx.
Okay, thank you.
Mm-hmm. So, so this is no longer traveling wave because time and space terms are not interdependent on each other. Another thing is, have you looked at the homework yet? Anybody?
I have.
So what do you think? I mean, there is some practice of phasors. Is there anything that looks weird or different?
I mean, a couple of problems I was able to solve, but there are some problems I don't think we'll probably cover like later today.
Okay. Yes, because I'm asking because there is, I think, one or two problems I will be covering with you today. But I want you to have a look at the homework so that you know what we are doing. Okay. Afterward, if you haven't looked at it, it's fine. Okay. So we said that we talked about standing waves, we talked about traveling waves, but we talked about traveling waves in the lossless medium. Okay, so in the lossless medium, we said that they will travel for infinite time, they will not, attenuate and stuff. But there are the possibility that we have traveling waves in lossy medium. So in lossy medium, because we know that real worlds or real mediums are lossy. Okay. So lossy medium introduce attenuation factor. E minus alpha x, and which means that it will attenuate with the time, okay, or with x, okay? So it does not have a J factor in it. So it's not oscillation in this, but it's an attenuation factor. So another thing is the parameter A is the A or alpha. Alpha is the attenuation constant. Okay, and it has Napier per meter units. Okay. And if you want to express your wave in a lossy medium, it will be expressed as where this thing tells you that it will decay with time. It will decay with x, sorry. So if I just draw at 0 time my lossy wave, so it will be something like this. So this factor or this decay is defined by alpha x. Okay, so that's how the lossy medium plays its role in. I think we learned about losses before too, so it's fine. But I will do two problems for you from the homework and as well as from the example. So tell me that there is example 1.5. You can do it by yourself. So I should do homework problem. Example 1.5 in the document. Because it has its solution so you can see, right? What do you suggest? Should I do homework problem?
Yeah.
Okay. Okay. Let me see. Okay, yeah, this is homework set. So there are two problems, number 6 and number 7. Okay. I will do number 6 and then we will look at number 7 as well. Okay. So I think these are two problems that may be a little bit tricky for you. Number 6 and number 7. Yeah, okay. So homework problem number 6, okay? So the problem is that consider a vector wave that is propagating in a homogeneous dielectric medium with permittivity epsilon, epsilon r, epsilon naught, and mu is equals to mu naught. If the wave has measured time-dependent electric field given by expression, this, you have to find out all of these things. Okay, another thing is that I think I did not define it, that when the wave travels in the light, like in the vacuum or in the free space, it travels with the speed of light, right? But when wave travels in a medium, should I define it? Wave in a medium, its velocity changes. So velocity in a medium is dependent on the medium's characteristics. Wave velocity in the medium dependent upon medium's characteristics. Okay, which can be defined in terms of its permittivity and permeability. Okay, so when we define it like that, our wave velocity changes with the speed of light as epsilon r mu r. So this is waves, this is medium's permittivity, and this is medium's permeability. Do you know about these things, permittivity and permeability? I think you should have learned in the physics, right? So let's say if the wave is traveling in the free space, it travels with the speed of light. But when it travels in water or some other medium, it changes, like the velocity changes based on the characteristic of the material. And these characteristics we define by their properties like permittivity and permeability, okay? So that's how wave changes itself. Like the speed changes itself. Okay. Okay, now I will do the problem. But I really want to look in the, like the example problems in the document too, because that will also help you in your homework. Okay, so let's do it. I'll write the problem first. if the wave has measured time-dependent electric field by expression so XYZ means when we were writing before, we were writing X and T. Here we are writing X, Y, Z, and T. It means that it's all three coordinates are active, right? We can see anything in any coordinate. So the wave is 2 pi 10 raised to the power 8, 2 pi into 10 raised to the power 8t minus 8 pi by 3 x a z. Okay, it means that it has the unit vector z in it. Its direction is in z axis. Okay, so we need to find frequency of the wave. We need to find wave number. We need to find wavelength. We need to find speed. We need to find relative dielectric constant, which is epsilon r. We need to find corresponding phasor. And we need to find phase of the phasor at x is equals to 0. Yes, so we need to find these things and we will start. Yeah. Okay, so you will do it with me, okay? We will do it together. Okay, so first, tell me that I can write this thing as right? Because my cos theta is equal to, no, my sine theta is equal to cos theta minus pi by 2. I think we have done this before. Should I move up to confirm? I just want to see we have done it here somewhere. In the past, oh, where is it? Somewhere here, right? Okay. So we are good till here. Okay. So what do you think is the frequency of the wave? One more thing I want to write. Then you will, it's more easy than to do it. So if I want to write this as omega t minus kx minus phi, okay, that it will make more sense. Now, tell me, what do you think is the frequency of the wave?
Will it be, yeah.
What? Would it be?
10 to the 8th.
10 raised to power 8, right? That's right. Jonathan, you said the same?
I was going to say the same, but yeah.
Okay, so A part is frequency of the wave, which is 10 raised to power solution we are doing here. Sorry, solution we have started here. And this is A. Okay, A is 10 raised to power 8. We are good. We can also write it as 100 megahertz. Okay. What is wave number? Here. Alex? Keith?
I would guess 8/3.
Yes. So it's the whole thing. K is 8 pi by 3. Okay?
That's the whole thing.
Yes, because it's kx, right?
Okay.
Right? So K is our wave number. So we will do K is equal to 8 pi by 3. Okay? Is it good?
Will the wave number ever be negative?
No,
Okay.
it's just K. It's not the sign. Okay?
Professor?
Yes. Yes.
Even if it's positive, would it ever be like WT plus KX? Then would the wave number be negative, or
No, no, no. Wave number is just a number.
always
It's
positive?
okay. So minus or plus kx tells you the direction of your wave, right? So wave number is just the number that you're picking out of it. Like the frequency is just the frequency number, right?
Yes.
Okay. Yes. And another thing I was thinking that I should maybe write it as plus and think that phi is minus pi by 2. I think so. Okay. Because here minus tells you the direction, but when we are tackling phi, we should be doing minus pi by 2. That's the difference between them. Okay. Yeah, I think that reminds me that I should do that. So this, if this is plus phi, then my phi is minus pi by 2. But it's minus kx and k is just 8 pi by 3 because it's just a number. Okay, the C part is, what is the C part? Wavelength. Lambda, what is lambda? Nick, what do you think?
Not really sure on this one.
Okay, but what do you think omega is? Can you see omega here? Okay. Jack?
Yeah, so is omega, is it like 2 pi over the wavelength?
Okay, okay.
2 pi f?
2 pi f is omega.
Yeah. 2
Yes,
pi
but
f,
you are
yeah.
talking something right.
And then you know that for the f is c over lambda, right? Or am I going?
Yeah. Okay. So f is equals to c over lambda. That's very right. Okay, and c is your speed of light. That's the general expression. I think you remember, right?
Yeah.
Yes. So you can also find your lambda like that. Okay, so let's say lambda is c by f, right? So what will be your lambda then? Can you tell me?
Yeah, I'll do that right now.
Yes. Something is wrong here.
You could also use the wave number,
Yeah,
right?
3. But that. Oh, no.
1 minute. Let me just check. But it should give you lambda is equals to lambda f. Okay. C is equals to lambda f. Yes. I'm just doing it wrong. C is lambda f. So lambda is C by f. No, it was fine. Under megahertz, okay. Yes, so what it is?
I got 3.
3, right? But why they have, So our wave number K is actually 1 minute. So it's 3 for you here. Okay. So it's 3, lambda is equals to 3, what 3? It's just 3, right? 3 meters.
2 meters.
But if you see, if you compare it with the normal wave number, so our wave number is 2 pi by lambda, and our VP is in this case, just a minute. Yes, K is 2 pi by lambda, sorry.
Does
Now I
the
know
book
what
say
I'm
the
doing.
answer is 0.75 meters?
K is equals to 2 pi by lambda, okay? And if you calculate lambda from here, it will be 2 pi by 8 pi by 3, okay? And your lambda will be 6 pi by 8 pi, and it will become 3 by 4 meters, which is different than your lambda that you have calculated here. I will tell you why, okay? But this is your lambda that you have calculated from your wave number, okay? This lambda is greater or smaller? What do you think?
Smaller.
More.
Smaller, right? So we will talk about it, why it's different than this one. Just remember this, that your lambda, when you calculated with the speed of light, it was different than when you have calculated with the wave number. But what do you think, what's the reason here?
Because it's not taking into account the wave number.
No,
Oh,
That is free space. So we
maybe, yeah.
yes. So you are thinking that this wave is traveling in the free space, right? That's why this formula is right. This formula is right. But this is the lambda when your wave is traveling in the free space. Okay? But because wave number has intrinsic medium thing in it, that's why this wave number is in the medium, like the lambda is calculated like wave is traveling in the medium. Okay, sounds good? Okay, we will see that. We will come back. Okay. Three by 5. Okay, 3 by 4 meter. Okay. So now D is asking us to calculate the speed or the phase velocity, okay? So if you calculate phase velocity using lambda f, so this lambda you will use, okay? Otherwise, if you know that it's traveling in the free space, you will just say that its phase velocity is speed of light, okay? But right now it's moving in the medium, so you are 3 by 4 into 10 raised to the power 8 is its phase velocity. Is it fine or is it confusing?
No, it makes sense.
Okay.
Dr. Khan, well, what's the difference between the other formula, C over the radical ER to the UR? What's VP?
So what, repeat your question? What you're saying?
I thought the formula for the velocity would be c over square root
Yes,
of e to the
that's, oh, okay. So you are thinking about this one.
yeah. Is that
Yes, we will use that, but this, okay. Okay, so yeah, that's a very good point. So if you see here, right, that's the difference it makes in this formula and in this formula, right? In this formula, you are using VP, right? And in this formula, I am using C, which means that I am thinking that it is traveling in the free space. And in this, I am thinking that it's traveling in the medium. So this formula is making a difference that tells that how phase velocity is different in the medium than the speed of light. Okay, but you are not using this formula, I'm just explaining it. You will use it when you have to find out the relationship between the speed of light and the phase velocity. Okay,
Quick question too.
yes.
For the C equals lambda times frequency, will we ever have to use that, you think, or no?
No, we are not using it.
Okay, all right. Thank you.
Because okay, like someone has said that this is the formula, which is right, but we know that we cannot use that formula because we don't know yet whether our wave is moving in the free space or not. Okay.
Right. Okay.
So we just calculated our lambda using K, and then we use this formula to calculate our phase velocity. If we were moving in the free space, our phase velocity would be equal to the speed of light, which it is not. So it means that we are not moving in the free space. Is it making sense?
Yes. Yeah, it does. Thank you.
Okay. Yes, so this you are not supposed to use when you are calculating your lambda, this one. But I'm just keeping it because it tells you the difference, that how the choice of formula can give you a different answer, even if you think your formula is right. Okay, we are good?
Yes.
Okay, so E part is what? Relative dielectric constant. What do you think? What relative, if I want to find out epsilon r, what should I do?
You use the VP equals C over the square root of mu r epsilon r.
Yes, I will use this formula. And I know I'm not given mu r because mu r is have some value when there is a magnetic material. So it's not, I think, magnetic material. So that's why my mu r is 1. Let me see. Yeah. So that's fine. Because they have mentioned that your mu is mu naught. Mu r is mu naught, which means that it's not a magnetic material. So my mu r is 1. And my formula is this, epsilon r. Okay. So my epsilon r will be equal to C over Vp, which will be equal to epsilon r C over Vp whole square. Okay. And it will be 3 into 10 to the power 8 by 3 by 4 into 10 to the power 8 square. And it will be 4 into 10 to the power 8. No, 10 to the power 8 will be canceled. And it will be 4 square. So it will be 60. Okay. So are we clear till here? Migo?
I have a question.
Yes, go ahead.
So if it says in the problem that mu equals mu naught,
Yes.
isn't the constant for mu naught like a known constant with like
4
Why
pi into
would-
10 to the power minus 7, I think. Yes.
Yeah.
Yeah. So, okay, I should tell this. So normally, I don't know whether you come across with this thing or not. Your C is equal to this thing. Do you know this?
Yeah.
Do you know this?
Yeah.
Yes. So that's what it is, okay?
Okay.
Or is the other way around? Just, I need to confirm it. So can you confirm that your C is 1 over mu naught epsilon naught, or it is? Yes, I think it is. So if I just replace this C as this, then it will be, I don't need to replace mu r, right? Because it is equal to mu naught. I just want to confirm 1 minute. So C is this, or C is under square root mu naught epsilon naught? Just a minute, I just need to confirm. Permittivity. Yes, it is this. Okay, so we are good. So, okay. So, okay, what I should say is that, so if you have this thing here, you can write it like that, right? Yeah, I think so. We are good. Something like that. But I just don't want to make you confused. Who asked me question this? Miguel, you did? Miguel?
I asked the question. Sorry.
Yes. No, it's okay. What I'm saying is that your speed of light is equal to this thing, right?
Right.
And your mu r is equal to mu naught,
Right.
right? So you don't have to write this thing as, because this will be canceled with this, the mu naught part, and it's automatically will consider as 1 because they both are equal. I'm not clear.
I mean, so if you write C as 1 over the square root of mu naught epsilon naught, and then write the denominator as the square root of mu naught.
Yes, I can do that. 1 minute, 1 minute, 1 minute. Yes, I can do that. I got it. So this is C is equals to mu naught epsilon naught, and this is mu r epsilon r, okay? Not C here, it's just VP here. So VP will become, mu naught epsilon r. So you think that it should become epsilon naught epsilon r, right? No. So this will cancel with this. No. How it will come like that? Yes, that's a good question. What should I? That's a very simple catch here, which I should be getting it. 1 minute. But I will come back to that, okay? I think it's right, but there is very simple thing that we are missing here. Okay, Migo? I will come back to that next class, okay? Just remind me that we have to do this. Okay.
Yep, thank you.
Okay, so we need to do corresponding phasor.
Professor?
Okay. Yes.
So the homework, it's due on the 22nd. I think that's the Monday. Do we leave like this portion blank when we're handing it in?
Which I am solving it for you?
Yeah.
No, I mean, you can solve it. Another time, one more time, it will reinforce it. It's okay. Okay. It's just fine that we are solving it. It's okay. Because some people may have not get it still if they are sleeping. Okay. It's okay.
Okay, thank you.
Okay. Okay. So F part is what? F part is determine the corresponding phasor. Okay. So that's what you need to tell me is that, so this is our X, Y, Z, and T. Real part, E, X, Y, Z, E, J, omega T. I can also write it as E naught, E, J, omega T, E minus J pi by 2, and E minus J 8 pi by 3 X, Z. Is it right? Am I right or not? Yes. Ria, what do you think? It's fine?
Yes, I think so.
You need the cosine at all?
What?
Never mind.
No, go ahead.
Oh, I was gonna say, do we need the after the E sub naught, do we need the cosine after that or no? I don't know.
No, you're good. So when we write cosine, I can write
Yeah.
cosine here. It will become omega T, and it was kx and plus phi, right? So we can also write it as real part of ej omega T, E minus j kx, E j phi, right? This thing.
Oh, okay. Thank you.
So we are good?
Yes.
Okay. Ria, you were confused what you were saying?
No, I think I got.
Okay. Okay, I think I also got this speed of light thing. 1 minute. So when something is traveling in some medium, your speed becomes like this. Okay, so this thing is in medium. When you are having mu r is equal to mu naught, then it will reduce to mu naught, epsilon naught. You do not have to write mu r because it's already equal to mu naught. So it will become this. And when it will become this, it will become C by epsilon r. Okay, Migo? It's just like that you have some factor that you need to multiply, but if you do not need a factor to multiply, you just write it as mu naught.
Okay, thank you.
Shouldn't the mu not be out of the square root or?
No. It's not like that you will multiply mu naught again. It's like that you know that this medium has the same mu naught, so you will not write it again.
Okay.
You got it, my point? Or
Yeah.
in other words, you can also say that in non-magnetic medium, your mu r is 1. Okay? So I think this is a little bit confusing that when they say mu r is mu naught, because you will not write mu naught for the second time. You will think that it should be multiplied with some factor if there is a value of mu naught. Okay? Are we good about this? Christopher, are we good about this? Talal,
Yes.
are
Makes
you
sense.
sure?
Yeah, for the most part.
Okay. Okay, so the G, we will be doing G. What is G? Where is my homework? I can see here from here, G. Phase of the phasor at x is equals to 0. Okay. So what do you think I should do? Oh, sorry, I first need to write phasor. So I did not write phasor here. I wrote it in terms of exponents, but I did not write the phasor. So let's see, I write the phasor. So what would be its phasor? What do you think? John? Yeah, go ahead. I mean, it's okay. You do not have to be right. What do you think? What should I write here?
Would it just still be the same coefficients because the exponential forms?
Yes, they will be same coefficients, but we will not include time harmonic thing in it. Like this will not be included in phasor. Okay?
Okay.
Yes, so phasor will only have the exponents which without the time thing. Okay. So E part now, why I need to write it? Because I need to have the phasor at x is equals to 0. Okay, in E part. Oh, sorry, not E, it's a G. G part. So it will be E omega x is equals to 0, y, z. Right? So what would be my phasor here? Andrew?
Is it just e to the minus j pi over 2?
Yes, why?
Because the e to the negative j 8 pi over 3x is just going to go to 1.
Yes, because x will be 0 and it will become 1. That's very right. Okay. So this will be the phasor now. So I'm just writing the unit vector in it. So I can also write this thing as minus j e naught z. Why? Because minus aj pi by 2 can be written as cos pi by 2 minus pi by 2 plus j sine minus pi by 2, and cos pi by 2 is 0 and it will become minus j. So e minus j pi by 2 can be written as minus j. Okay? Sorry if my unit vector is sometimes z and az, it's just the same thing. So are we clear about this? Yuri?
Yeah, I'll probably look it over one more time, but it looks good.
Do you think I'm fast? Here? Is it? It's okay.
Nah, you're fine. It's just a lot of material. It's not really you. It's just
Okay.
a lot to grasp. That's all.
Okay. Josh, what do you think?
I think mostly it makes sense. I just have one question.
Mm-hmm.
For part F, when you put it into the components of real, how come the amplitude of the cosine goes into the real portion of the
No,
signal?
no. I mean, you can take it out. It's just a constant. Okay.
Okay. That makes sense.
It
Thank
just doesn't matter. You can take it out as well.
you. Okay, cool.
I have a question about that last part.
Yes.
So is that whole negative j times the E naught and with that unit vector, that's the whole phase, that whole thing? Or is it just the minus j?
Sorry. So you are talking about G part?
Yeah.
So in G part, E minus J pi by 2, why I wrote that? Why do you think? Why I did not write 8 pi by 3 in it?
Well, because the x was 0.
Yes. So now EJ pi by 2 is the whole thing, right? For x is equals to 0.
Yeah.
But why I replace it with minus j? Because it is equal to minus j.
Yes, I understand that. But
Okay.
so like, because it's a phase angle, right? So
Yes.
do you need that like E naught, that amplitude there as well for the phase only?
Okay, that's what you are saying. Yes, I think for the phasor you need that. I think they are asking about determine the phase of the phasor. I do not mind if you do not write that, but I think if you write that, it's also fine. Okay.
Okay.
Yes.
That makes sense. Thank you.
Yeah. Okay. Anything else? I spend more time on this question because I feel that it's a good way of understanding what we are doing. Okay. So, I mean, this question was looking a little bit difficult, but it is not, because if you try doing it with all the information you have, it is very easy to do it. So are we good about this? Louis, what do you think?
Yes, perfect. Thank you.
Okay, so I will touch 7th question a little bit. I will not solve it, but I will just try to formulate this for you so that you may find it easy, okay? So the question in this 7th question is, consider a vector wave that is propagating in air. They already mentioned it. So there is no epsilon naught r involved in it. If the vector is given in the phasor form as, so this is your 7th question. Oh, what happened? So this will be equal EJ pi by 4 AX minus E minus J pi by 4 AZ EJ pi Y. So in this question, if you see closely, they did not write omega t part in it, okay? They wrote, what you should say, space part in it, and they wrote as well the phasor part in it, but did not write omega, which is fine. Actually, they are dealing with the phasor. So you just do not need to worry about that, okay? You can find, what you should say, wavelength. How can you find wavelength in it? What do you think is the wavelength here? Eric?
Hello. So we can find, let's see, that minus that.
It's okay. I mean, if you just compare this scenario, keep this in mind.
Yeah.
Compare this thing with this thing.
So
they look same, right?
Yeah, we can use the exponents for finding that. We have
Yes. So let's say if I say this and this does not have any X or T in them, right?
Right.
Right. So this might be the phase, like the phi thing in it. Right?
Yeah.
But this thing has X or Y or Z in it. Right?
Yeah.
What it suggest then?
Would we be able to find the wavelength using K as pi, or?
We will
No.
find wavelength as K, but why, from where the pi, yes, that's right. K is equals to pi, yes. So
Yeah.
how we will be doing that?
So if K is pi, then we know, I think it's 2 pi over lambda equals K. So
Yeah, got it.
Yeah.
Yes, that's right. Yes, okay, that's very good. Cedric, are we good about this?
Yeah, it makes sense so far. Just one question. On the very end of the equation, like over number 7, is that e to the j pi y?
Yeah. Yes. Sorry, my writing is so bad. Okay.
Thanks.
Okay, yes. Okay. Okay, I'm not solving it. I'm just writing it. Okay, so B is frequency of the plane wave, which you can find from the lambda. Now, the C part is interesting. The corresponding time expression, okay? So, if this is the phase, I want to write corresponding time expression. I will do this. And I will write the whole scenario in, which is j pi by 4 ax minus e minus j pi by 4 az aj pi y ej omega t. Right? So can you write now from there? So this will become ax okay? And I will stop here because from here on, you should be able to write the time domain expression. Time domain expression means that you need to write it in terms of cos omega t. Can you write it? Should I write the first part of it? I can just do this. Now, can you write it? Bryce, can you just tell me the first, the time domain expression, if you...
Just so I'm clear, like that's like when it's in the cosine form.
Yes,
right?
yes,
So you just want the first statement?
yes. Just tell me what it will be in the time domain.
Cosine omega t plus k sub y and then plus pi over 4.
So that will
Times
make
x.
pi y,
Yeah,
right?
pi y.
And then this will be j pi by 4, right?
Yeah. Yep.
No, not j. I should not write j. So that's pi by 4, right? That's fine. Yes, good. Okay, we are good about this then?
Do you need to multiply that expression by 2? Or no?
Which one?
The cosine.
Okay. Okay. So when we are writing it in terms of time domain, right? So we are just converting it in terms of time domain. We are not trying to do standing wave conversion, but you're right. We can look into that. Can we separate certain like the constants and multiply and divide by 2? Let's see. Okay. So in this scenario, there are 2 things that are different than this. Okay. So this is, and this is different than this is, and this is. Okay. So can we, the question is, can we take the time part out of space part here? I don't think so, because there is a time part, there is a space part, and there is a phase part as well. But when you were trying to derive standing wave equation, if I just come back here, where was that? Here. So there was no phase part, and your space part was plus and minus. Okay, so let me see. Here our phase part is, can we do that? I do not think, because our phase part is both plus here. Okay, we cannot take it out of the scenario. Even if we do this, I'm making it more confusing, but let's see. So even if I do this, pi y, and in the scenario j pi by 4 plus e minus j pi by 4, that's what I think you meant, right? Even in this scenario, if I multiply and divide by 2, I will not get rid, I cannot separate the space and time part from this. So it is of no use. Okay. The idea is to separate the space and time part from each other to see if they are standing waves or not. So here they will all the time will be interlinked to each other. We cannot separate them. So it's not a standing wave. Okay.
Okay, thank you.
Josh, is it clear or is it confusing?
Yeah, I think that makes sense. Thank you.
Okay. So we are good then with the homework. Do you have any other questions? You haven't looked at it, so how do you know that you have questions? Right? Okay, but I think with the best possible scenario, I made it easy for you, the homework. Why? Because I think these were the most difficult questions. And if you were able to understand them, you can also able to solve the others, okay? So even if you think that there is a problem, I mean, in the homework, you can email me and maybe join me in the office hours. But what I mean, we can see what is the problem and whether this problem is difficult or whether I should discuss it in the lectures. But other than that, I think now homework should be good for you, okay? Okay. Okay, sounds good. There is a minute paper. We will be coming back to interactive questions again once we will cover some more material in theory, like related to antennas. But right now I wanted to make it simpler so that when you will be going and dealing with EJ things, it will not be, you know, something out of the world for you. So that's why I wanted to make it a little bit more comfortable. So yes, that's about it.
Thank you.
Thank you.
Thank you. Have a
Have
nice
a good
day.
day.
Have a nice
Bye.
day.
Have a good one.
Uh,
Thank you.
Thank you.